This is Algebra 1, Semester 1. It's the unit called Graphing Linears, and it's the third unit. And it's the lesson called Graphing Linears in Standard Form Practice. It's a lesson number 10. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book according to the table of contents, with the notes for those pages from creatormath.com. So I always try to show where those notes are right now and how to find those page numbers, because that's a little bit difficult oftentimes for students. So here's the actual website name, creatormath.weebly.com. If you Google that, hopefully you can get to this homepage. Looks like this. If you have any questions on the composition book, please scroll down to where it says composition book and read all the instructions, watch all the videos, follow all of the due dates, and put everything on the pages that it should go, as well as notes, which we'll look at now. The notes are under the tab along with vocabulary. If you're not getting 100% on your vocabulary practices, then you may not know there's a complete PDF that is here under the tab of the class you're in or the video we're making, and this is downloadable to your device and it is searchable. So just Google how do I search a PDF with whatever type of device you're using, and it will explain to you. It's a little bit different for each device. Next, find the semester that we're interested in. So for this lesson, this is semester 1, and it's the table of contents here, which you should have already written in full on pages 2 through 6 of your composition book. If you haven't done that already, please stop this video and go back and do that. The reason the table of contents is important is because it lists the page numbers for every set of notes and every lesson, and gives you the notes and gives you the problem set and the video solution. Right? So we're going to go now to the unit we're in, which is graphing linears. These are all lessons within that, right? This is lesson number 10, so we're way down here. We've done a bunch of these. Graphing linears in standard form. Here are the page numbers upon which these notes should be written. Please don't use this video to determine which pages to write them on, but go back and find the original table of contents. At the time you're viewing this, these page numbers likely will have changed, so don't use this video's word for it, okay? Here are the notes. The problem set is what we're going to do right now, and the video solution will be linked here when we're done. So click notes. Sometimes I have to click it twice to open it. So this opened right away. I don't know whether it's the memory in my phone or my internet connection or what, but this is going to talk about the slope-intercept form of a line. Let me try to make that a little bigger so you can see. So y equals mx plus b is the slope-intercept form of the line. ax plus by equals c is the standard form. So this is graphing linears in standard form. We're going to be dealing with this ax plus by equals c format of the line, and we'll show you how to convert these back and forth. It shows you down here in the notes. In both, x is the x-axis and y is the y-axis. So notice an x and a y and an x and a y. They're in different sides of the equals sign here, which is what constitutes the different format of the equations. In y equals mx plus b, b is the y-intercept and m is the slope, hence the name slope-intercept form of the equation of a line. Purpose, easy to graph. Yeah, that one's easy to graph. This one, the standard form's a little bit harder. I'm going to show you some ways around that, but basically speaking, we need to either use algebra to turn it into y equals mx plus b, or we need to go ahead and just have some little bit understanding of what's where, and we might be able to graph it that way. So a, b, and c are the coefficients. A is what's in front of the x, b is what's in front of the y, and c is a constant on the right side. So technically speaking, c is a constant. And useful in setting up equations to solve word problems. Okay, I'm going to let you put that in your notes. I'm going to focus on this right here in the standard form equation ax plus by equals c. The x-intercept is when y is equal to 0. So if y is equal to 0, then the 0 zeroes out this term in the equation. So now ax equals c. Divide both sides by a here and here, and we get x-intercept equals c over a. For the y-intercept, x equals 0. So again, repeat where a is multiplying out to 0 because it's being multiplied by 0. And we have by equals c, divide both sides by b, and the y-intercept equals c over b. And we're going to show why the slope equals negative a over b. So with that in hand, there are some other vocabulary here, some practice problems you're going to put into your notes that will help you just get a better understanding of what we're talking about. And now let's turn our attention to the problem set. So it says, what's the standard form of the equation? Standard form is this, and it's written ax plus by equals c. And that's it there. This is the slope-intercept form, and this is actually a standard form of a parabola, because it's got a quadratic. There we go, because it's to the power 2. All right, so it might be nice if this said, what's the standard form of the equation? It would be nice if it said of a line. I'd like that in there. All right, what is the value of x when the graph crosses the y-axis? What is the value of x when the graph crosses the y-axis? The answer is 0. So what does this mean? This is a little bit cryptic the way this is written. If this is x and y, what's the value of x when the graph crosses the y? So say you got a graph crossing right here. It's intersecting or intercepting or crossing the y-axis right there. What is the value on the x number line? Well, it's right in the middle, so it's got to be 0. So x equals 0 when we are crossing the y-axis. Okay, and that's what this is asking. It's a very important point. We'll show it again down here in a bit. We'll ask it a couple of different ways to see if we can make it more clear. What is the value of y when the graph crosses the x-axis? So here's the x, here's the y. Remember, these are always the same way. X is always horizontal, y is always vertical. It does not change. It's foundational to the entire practice of graphing. What's the value of y when let's see, so what is the value of y when it crosses? So let's say you got a graph like this, right? So it's crossing the x here, so it's crossing the x-axis right here. What is the value on this y number line? Got to be 0. Y equals 0 for this point where it crosses here, okay? 0. So given the standard form of the equation ax plus by equals c, if we want to find the y-intercept, what do we do? So this is just what we said. If we want to find the y-intercept, so what we have here, that's where x is equal to 0, just right like we said. Here's the y-intercept, x equals 0. So we say a times 0 plus by equals c. That's going to make this whole term disappear. We're going to divide both sides by b in here. And we're going to get that the y-intercept equals c over b. Okay, so this answer right here. So y equals c over b is the final answer you're looking at. And it explains, replace the x value with 0, or a times 0 plus by equals c, which becomes by equals c, divide both sides by b, and get y equals c over b. Given the standard form of the equation, here, what if we want to find the x-intercept? Well, up here we said if we're on the x-axis and it's intercepting, the value of y must be 0. So now we're going to go here and say b times 0, because the value of y is 0 at the point we're looking for, which is the x-intercept. Then this disappears. We divide both sides by a, and we get x equals c over a. So here it is explained, replace the y value with 0, or ax times b times 0 plus b times 0 equals c, which becomes ax equals c, or divide both sides by a and get x equals c over a. Okay, so interestingly enough, given this standard form of the equation, what we have now is we can find the x-intercept and the y-intercept just by taking either c over b for the y-intercept or c over a for the x-intercept. All right, might be nice if I put int right there for intercept. So we don't have to rearrange the whole equation, and I'll show you that way too. That's the way your teacher probably is going to ask you to do it, is say rearrange the whole thing. And you can do that for the first couple, but at some point, we're done doing that. Let's move on and get this thing done, okay? So given the standard form of the equation, how can we find the slope? The slope is negative a over b, and now I will solve this for you. Let's go ahead and say we've got ax plus by is equal to c, right? We want to solve it for y equals mx plus b. So let's subtract ax from both sides. Disappears here. And we get by equals c minus ax. Okay? And actually, I might keep it, I'm going to rearrange the order. I'm going to keep it minus ax plus c, like that, because I want the mx plus b, and I'm already starting to get that. Divide everything by b. Okay, and this disappears. So what do we have here? We have y equals negative a over bx plus c over b. So we already said that the y-intercept, which is this looks like y equals mx plus b, right? And this is the y-intercept, c over b. We already said the y-intercept is c over b, so that confirms that. And we are now saying that the slope equals negative a over b. And that's true. M equals negative a over b. Okay, we proved it right here. That's what the slope is, the value in front of the x. And so that's the m. That's the slope, negative a over b. So that proves this right here. Okay, that's this one here. Check. So now let's look at a few problems. Let's see if we can apply what we've learned. Given 3x plus 4y equals 12, what is a, b, and c? So this is pretty simple. A is 3, b is 4, and c is 12. That's the format. Ax plus by equals c. So see how c is 12. See how the number, the coefficient in front of the y is 4. That's b. And the coefficient in front of the x is 3. Right? So pretty straightforward. That's a, b, and c, those values. And that's what we're going to use to now go straight to the x-intercept. So this says given 3x plus 4y equals 12, what's the x-intercept? We know that the x-intercept is equal to c over a. In this case, c is 12 and a is 3. So 12 over 3 equals 4. So that means when we start to graph this, the x-intercept is 1, 2, 3, 4. It's literally right there. We know what it is already because we found it right here. All right, so let's circle this. 4, check. And keeping the same information up here, with the same equation, 3x plus 4y equals 12, what is the y-intercept? The y-intercept is, so we know that y-int is equal to, this goes to 0, y-intercept is equal to c over b, okay, is what I'm trying to get at. C over b is equal to c we said is 12, b we said is 4, so 12 divided by 4 is 3. So this is the y-intercept. So now I can go 1, 2, 3, literally draw the y-intercept here. And guess what? Now we have the graph of this line without converting it over into the y equals mx plus b format. Now a lot of your teachers are going to want you to do that, and that's fine. I do it too. But I also want you to know you can graph directly. And of course they made the numbers nice for us, right? The 12 divides evenly by 4 and 3, so things can get a little messy where this doesn't work as nicely. But for the moment, it works very well. And we might check the slope of this, right? Remember, we said that the slope of this line, and let's check it. Let's go 1, 2, 3. So negative 3 is rise, and run is 1, 2, 3, 4. So we know the slope is already negative 3 over 4 just by looking at our graph line. Let's calculate it here. We said the slope S, slope or m, equals m, which equals negative a over b. We already said that. A is 3, b is 4. So negative 3 over 4 is equal to this. Check, check. Right, negative 3 over 4. So we can literally graph these lines without converting to the y equals mx plus b. Okay, doing it again. We're going to do it a second time. A is 3, b is 5, c is 15. X-intercept here is going to be, this goes to 0, so you have 15 divided by 3, which is 5. The y-intercept is going to be, this is 0, so you have 15 divided by 5, which is 3. And now we have enough to go y, 1, 2, 3, and x, 1, 2, 3, 4, 5. And again, draw a line through these. And we can check the slope. 1, 2, 3 is negative 3 over 1, 2, 3, 4, 5 is run. So negative 3 over 5, which if that's negative a over b, negative 3 over 5 right there. So that checks. And match the graph with the correct. So now they're giving us, now we're looking at which one has an x-intercept of 1, 2, 3, 4. So the x-intercept is where this one goes to 0, the y goes to 0. So we divide 12 by 3, that's 4. So it's going to be this one, I already know. 3 divided by 15 is 5, that's out. 3 divided by 15 is 5. That's out. All right. So we're just quickly going through. The x-intercept is c over a, right? 12 divided by 3 is 4, and that matches here, 4. The y-intercept makes the x go to 0, so it's 12 over 4, which is 3. 1, 2, 3. Check. It's got to be this equation. Right? So just another way to see, and they gave us several of these. Looks like, do it again. So here the x-intercept is 1, 2, 3, 4, 5. So which one has an x-intercept of 5? That would be c divided by a. It's this one here. This one has an x-intercept of 12 divided by 3, which is 4. So no. This one has a 5. So 15 divided by 3 for the x-intercept is 5. It could be this one. But look at this. This is negative. So the y-intercept is c over b. In this case, c is 15 divided by, remember that b carries the sign with it, so negative 5. So this equals a negative 3. So this now is out because we're at a, or 15, let's see, for the y-intercept. Yeah, because this is at a positive 3, it would be down here at this for this equation. Okay, negative 3. So I didn't mean to put an x there. I meant to say no, it's wrong. Okay, that's what I'm trying to say. All right, which one is this? So 1, 2, 3, 4, 5 for the x-intercept. So let's look. Here's the x-intercept would be 15 divided by 3. Could be this one. X-intercept would be 15 divided by 3 would be 5. Could be this one. X-intercept would be 12 divided by 3 would be 4. This one's out. Now for the y, this one needs to be negative because it's 15 divided by negative 5 is negative 3. Check. It's this one. This one would be 15 divided by 5 would be positive 3. It's not positive 3. It's not up here. It's down here. So it's got to be this one. All right, make sure you're matching up the title of the video with the problem set you're doing. This is Algebra 1, Semester 1. It's the 3rd unit called Graphing Linears, and it's the 10th lesson called Graphing Linears in Standard Form Practice. It's on creatormath.com under the Algebra 1 tab, and hope this helps.